someone. Okay, so today we're going to talk about exceptions, as you can see. We already mentioned exceptions, and we even saw them, and some of you used them. We're going to not look very much deeper, just a little bit deeper from what most of you already know, and we'll explore a few examples. It's going to be much lighter than the previous lesson, which was a 3-hour lesson. I guess this one will be a bit shorter and lighter, and I hope better understandable. So we're going to see what the exceptions are, how they're handled, how they're thrown. A little bit now that we know a little more about classes, we're going to see how they work as classes in the hierarchy. We'll see how they are thrown, and a few words about best practices. So, what are exceptions? We've seen exceptions. They are related to the flow of our program, and actually they are going all the way down to the operating system and the relation with the .NET framework on top of the operating system. So that there are some exceptional flows in our program. Whenever we have some unusual events, let's say a program can raise an exception. That means it's throwing, the right term is throwing an exception, and if nobody is catching and handling this exception, it can go all the way down to the operating system and your program will crash. That's the usual scenario. And if there is no development environment installed or any other way, the user will just get a window that the program is crashed. Sometimes it will get also the description of the exception, what went wrong, but many times it will be hard to say really what went wrong unless you know the program, the software, the code. And that's it. In the framework, there are many classes that in certain operations, in certain scenarios, will throw an exception. So we've seen exceptions, and actually exceptions are classes. They're implemented in the framework as classes, and we'll see that they actually have some kind of hierarchy. And if a program throws an exception, we can catch it at certain different levels, and we always get to the basic class, the most basic exception that we can always catch in case we didn't catch it in the previous attempts to catch it. And if we are throwing it from within a method, which is called by another method, we can always get it on the way, because it will go all the way back up to the callers. And if nobody catches it, it will keep going up until it reaches the operating system, and your program will stop executing. So that's one thing, and it's important to know the exceptions and to handle them nicely, and to let your program know when something went wrong, instead of crashing it on the user, to handle them gently. What? Okay. So we've already encountered this structure. If we want to handle an exception of the code, we wrap our problematic code, or the code that we can expect it to throw some kind of exception, with a try block, and then we should supply a catch block. And with the catch block, we have an option to say we want to catch a specific exception of a specific type. And we can also access not just the type, we can also access an instance of the exception that was thrown, and we can see some of its properties. For example, if there is some message that says you were trying to do some this and that, or you have a bad argument in the function call, it's not supposed to be null, and then it can also tell you which argument it was. So in the catch block, we are catching a specific exception. We can specify more than one catch block so that we can catch different exception types. Here's an example. We are reading a string from the console, so far this method will always return a string. The read line always gets back a string, so we are populating a string. Otherwise, we won't be able to build this program. And now we're trying to parse the string into an integer, but it's not always that our string will contain an integer, because the user can type whatever they want. So we can have, here we're trying to parse whatever the user has typed, but they can type pretty much anything. So we can have multiple options. For example, if the user has typed a number which is too big to be parsed as an integer, we can catch an overflow exception. And if the user typed something which cannot be parsed as an int at all, we'll catch a format exception. One thing about this, for example, if we go to the MSDN library, something like, here's a method we've overlooked. We have a description of the method all the time. We have its structure. We can see it in different languages. So if you're implementing in VB.NET, you can see how the function signature looks like in Visual Basic and how it returns. We can see, for example, if we go back to the C#, that parse, which is a static method of the int class, which is under the system namespace. Now we can more freely talk about these with these terms. Receives a string, which here the variable is called s. And we can see that s has to be of type system.string, and it has to be the string in type to convert. Furthermore, we can see here that this method can throw several types of exceptions. So if you are exploring some new function that you don't know and you're going on the MSDN library, which is the right thing to do because that's the most official coverage documentation of the .NET framework, you can see also, as part of the description of a method, you can see what kind of exceptions it will throw. For example, if we're sending s, which is null value, we'll get an argument null exception. And if we're getting s, which is not in the correct format, for example, the user typed some kind of name instead of a number, we'll get a format exception. Or if we got some number which cannot be matched into a minimum value to maximum value of an integer, we'll get an overflow exception. So this helps us understand in the function that we're calling what kind of exceptions we can expect. And if you don't know what the user is going to do, for example, if we're using a console, they can type whatever they want. If we're using a Windows application, we can control what they're typing, and we can limit their types with some validators, or we can catch the event when they're typing on the keyboard and not accept certain characters. But in our case, we're getting it from the console. They can do whatever they want. It's unlikely that our string will still be null because we are initializing it with a return value. But if by any chance someone gets this function call with null, we can also expect an argument null exception. If you want to see details about the exceptions, you can also go into the code here, and you'll see the hierarchy of how these exceptions are structured in the hierarchy of the framework types, and you can get all kinds of information about it, what it contains, what kind of message, all kinds of useful information if you really want to explore the specific exception. As you can see, the exceptions are classes, and we'll see that today too. So that's quite useful information, and if we're building this application, we can expect at least these two exceptions here. So we can specifically catch the format exception, and we can give the user a nice message on the go instead of just crashing in their face. That's clear? Okay, let's see it. We are still running, right? So here is the code.
Can I ask something?
Sure.
How you are getting these numbers inside the code?
How am I getting the numbers to parse?
The raw numbers.
Ah, that's, I think, in the tools options. There is such an option in the, maybe in the text editor. In here, line numbers, yes. And there's also another, if you're working with bigger solutions, like usually people do, there's another feature here which tracks the active item in the Solution Explorer. So if you're opening some kind of file which you don't know where it is, it will show you in the Solution Explorer exactly where it is. So when you navigate to another file, it will mark it here on the Solution Explorer, or Navigator in this case. In this case, it's not really necessary, but if we have really big projects and I'm starting to look for a certain file, for example, like this, I can see some types and I'm opening a file and I'm not sure where is it, I can see it tracked down here. That's very useful for big projects. So we are reading the console line. Let's get something which is not a number at all. So here's our string. And we're trying to parse it inside a try block. And the parse method through the exception. And we are catching it in format exception. We can get some, details. Format exception was caught, and we get some message. We can see the details of the exception itself. For example, we have a message that says something and some other fields. Some of them are useful. For example, I can see here the stack trace. So I can see if I drop it down, it's too wide. It's too big. Yeah, if I look here at the stack trace, I will see the methods that were called in order to throw this exception. So our first method was main that was called, and then main called parsed integer 2. And then parse integer 2 called string to number method, which is under system number. And that method threw the exception, and the exception went all the way back, and we caught it in main. We're printing a nice message, and we are finishing the execution gracefully. If, for example, S would be null, and I know that parse, if it receives null, throws a null argument exception, which we are not catching. So again, we're reading, but that will be ignored. Read something. Here's our string, but we are setting our variable to null. And now we're trying to parse. We got an exception that nobody caught. Argument null exception, value cannot be null. The parameter is the string. And we cannot continue from here gracefully. If I run it without debugger, we got a crash. The program stopped working, blah blah. And we have the CLR exception, blah blah, system argument null exception, but that's not really nice to give the user a program that crashes like this. And they have nothing to do really, and I'm sure all of you have encountered crashes in programs, and then you have nothing to do but to close it. And here's the exception in the console. Let's give a really big number. So we got a long string, and we're overflowing because we cannot fit it into an integer. It's greater than the max int. Nice message. We're done. After we're done with the catch block, we're executing the rest of the code. So actually, the fact that the catch is here at the bottom of the software, at our program, doesn't mean that we can't continue. For example, we can read another string. So the flow of our execution will go into the try block. If something happens, it will go into one of the catches. And once the catch is over, we're continuing the flow. So you can wrap any piece of your code with try whenever you need it's necessary, you think it's necessary, and put catch blocks accordingly. And that's okay. If you're not sure what kind of exception is going to be thrown, you can just catch the most basic exception, which is called exception. So if we have here a null argument, here we are, and since none of these was able to catch it, we're falling to the one that does catch it, because that's the most basic one that will always catch.
Can you put if statement in the common exception?
You mean to detect what kind of exception it is? Yeah, you can. Although in this code, we are only catching the type of the exception. If you want to catch an exception and inspect it, that I think will be our next example, but I'll show it already. I can define an argument here with a name, and let's not read it for a minute just to save some execution time. Yeah, okay. So we're trying to parse null. We're going in here. We can inspect our object of the exception. We can see from here already that this exception is an argument null exception, and you can also say that's a neat Boolean notation of C# that can tell you whether a certain class a certain object implements a specific class. And so in this case, I could put, for example, this condition here, and write some code here to handle the specific exception. I could also do it more neatly with a switch. Although not sure that will work, because it's not really a comparison. We're not comparing an object, we're checking if it's implementing a specific class. So the right way is to say if the current exception object is something, and handle it. But this is an overkill, because I could just put a catch block specific for the exception, and that's it. It's much neater to do it like that.
If we are catching the one exception first, and this format exception is going to catch the format exception, or did you catch the old?
So yeah, if we the exceptions are going from the first caught to the last. So if we take the most general one and put it first, it's going to be caught first. We're not going to catch the specific exception. So instead of reading from the console, I'll just put some string which will not be parsed as a number. Put a breakpoint. No. Yeah, actually, yeah. It's already. Yeah, it won't let you build even. I thought it would let you build and catch it correctly, but it's like you're putting code which is not accessible. Yeah. But yes, the expectation here is that the first one will, the more general one will be caught first, and then.
No, it's better that we have different exceptions and not just one general.
Because in different scenarios, you would want to handle them differently. If a user put a number too big, maybe, well, in this Genius program, there are not many options, but if you have a big application and there are many scenarios where you can fail, or let's say you have complex classes with methods that are calling other methods on other classes, and somehow, somewhere in the more general piece of code, you want to catch all kinds of exceptions, and then you can handle them differently. So, yeah, that's a powerful tool. More questions about this example?
We continue to use this code, but we don't have variable which is catching the parse.
Mm-hmm.
The parse method. If we are catching the parse as a variable, for example, integer a, and then we are trying to use it after the exception.
Mm-hmm.
How the exception will handle it, because it will be 0. Or what? It will be
Do you mean
0 or what? Okay, let's say we have integer a, which is parsed with the s, which is
But parse doesn't return a value. But I see what you mean.
what is going on with our variable after the exception?
Yeah, we can define we cannot define it here, because after the exception, if we define a variable in this block, it will only be valid in this block. So let's put an integer here, some I, and instead of doing a parse, nope, what's going on? So we'll assign it here, like this. You mean? And we're going to fail. Okay, since this statement is going to fail its execution, it's not going to reach the end of the parse method. Somewhere before it finishes, there'll be an exception thrown. So there will be no return value here. We also saw that in a method. When we were talking about methods, we saw that a method can return a value at any point, but it can also throw an exception. It will be. These are two different options of how a method behaves. So if one of the methods on the way throws an exception and doesn't reach its purpose, then this statement will not finish running. So if I here is uninitialized or initialized to the default value, after the exception catch, we will have 0 here. We'll continue having 0.
In this case, it will crash again because it's not initialized.
most probably.
Try to write it.
Let's try to write it. Yes, unassigned. You're right. You can initialize it and then check it.
Yes, and then we can
Yeah. Or what happens if we put if we put our line here, then we will not reach this line, because once we run this line, we're going to be thrown to the exception, and we're not going to reach the other code here. So this is legal, but yeah, it's legal, but you need to know what you're expecting, that this line may not be reached.
But there is no point to write all your codes after the try, because it will be some kind of hard to read code. I mean,
You mean after the try here, down here, or in here?
in try.
It depends. It depends on your...
code in try?
I'm wrapping specific codes in try-catch blocks wherever I'm expecting an exception, and that really depends on how you organize your flow. I mean, at some point we want to catch the exception on a specific action, and then we want to continue executing. So we'll either put more code here, and we know that at a certain point we will not reach it. But if, for example, there is no exception, then we want to print a nice message that you entered a valid int in this case. Or we want to call another method here. And if we're catching, we want another flow. And in any case, we can continue with something else. That really depends on what you're doing. But it's possible. All the options are there. The tools are in your hand. It's up to you to decide the flow of your program.
And the other thing maybe I will learn after that, can we write our own exceptions?
Yes, you can. So we've seen that an exception is really a class. The basic class is System.Exception, the most basic one, and all of the others are inheriting. We'll talk more about inheritance in the future. We've seen that an exception has a message that contains the details of what happened. It has a stack trace that shows you what was the position of the stack in the function call, so we can see which function called which at the moment of the fail. And sometimes an exception can encapsulate another exception. So that means that you have a big exception which was thrown, but it was actually thrown after catching a smaller exception, and it can contain an inner exception that will give you more details about what really went wrong. And that sometimes happens. So this is another field of the exception class, and different exceptions can have different classes and different properties and different implementations of the properties, but these are the basic ones that are always there. And if there is no inner exception, this field will be null. So this is exactly what we just did, only that it's going to be in a method. So we have a static method called format exception. We can see that this code will cause an exception to be thrown because we're trying to parse an invalid string. And although we are trying to run the method here, it will be thrown here and will be reverted back to catch it down here. And we are holding an object which holds the format exception, and we are exploring its properties, printing them out. It's exactly as what we just saw. This is clear now, right? So again, the message gives a brief description of what happened. The stack trace will show you where the exception happened, in which function was called, and you can get a better idea of course, in this case, there is not much because we have only main, and then we have our cause format exception that was called, and then we have our int parse, and then we have our parse int32 of number. So this is quite an easy way to, an easy flow, but if you have big applications, many classes, many functions, many methods, somewhere it was thrown, this stack trace is very useful to give you a really point on where it happened, because many times it will happen because of you, and you'll have to know where exactly in your code it was thrown. So this part here of the main and our code is the important bit to know which of our methods were called and in which order. Yeah, we can see here that also it doesn't only give the method, really, it gives you the actual file that was the error was on and in which line in the file it was. So not just main, you can actually go to the exact line where the exception was thrown and inspect it. So here's the output. We're getting the message and we're printing out Let's start from main. Oh. So we're starting from main. Here's our code, calling the method. Let's step into the method. So we're now here. Here's our string, calling parse. And we're catching it on the nearest catch. We could have put the try catch here, but since there is no catch here, we're catching it on the caller. And once we step in, we'll have an object that we can see its properties. Here's the message. Here's our stack trace. We can expand. Lost it. Ah, here it is. So main, then the cause, then the other methods, and all the other optional. And here's our information. Exception caught, so we have the type of the exception, we have the message of the exception, and we have the stack trace printed out. It was mentioned that once we run our code in release version, we might not get all this information formatted exactly the same way, but actually I think it is printing pretty much the same. Just giving the information in any case. Okay, questions about this? So, we still haven't explored inheritance and hierarchy of classes, but this is a very small, limited map of the exceptions because the CLR, the .NET framework, has many types of exceptions. These are just a small subset of them, but you can see that there is actually an inheritance, and you can always catch the more basic exception. You can always reach to the system exception, which is always at the root level, but you can, if you know a specific exception type, and you can, as we saw in the MSDN library, you can see the hierarchy of the specific exception. You can know, for example, to catch all the exceptions of a specific type in one place. And that's good to know that they are hierarchically organized in the framework. So all the exceptions inherit from system exceptions. And these are other types inheriting from it. And there is an option, like I was asked, there is an option to define your own exceptions, and you can inherit from a class called application exception. You can provide your own exceptions, and then you can throw them and catch them as you want. So you can have more control of, if you're expecting certain thing to happen, or if you have some code that analyzes a string and you want to throw your own exception, you can provide that too. Maybe we'll have a look at that. So we already saw that we can catch, for example, system exception, the most basic one. But again, you can catch anywhere on the level. If you know what's going to be thrown and what's the hierarchy of it, you can catch. So here you have some code that can catch arithmetic exception. And if we dive into the MSDN library, we'll see that arithmetic exception has some inheriting classes, divide by zero exception and overflow exception, and if any of those will be thrown, we're going to catch both of them here. So that's the value of this knowledge. Okay, we already know the mistake here, right? We just saw that. Yeah. So we have here a catch that overrides the other catches. So we have some unreachable catch blocks here, and that's our problem. Yeah, you don't have to catch a specific exception. You can also do a try-catch block without anything, and that means that in this case we'll just catch anything that will be caught here, anything that was thrown. So this is also a valid syntax. We can put a try and a catch without any specification of a specific exception, and any exception will be caught here. But we will not be able to explore or print out, for example, the properties of this exception. We'll just catch it and do whatever. By the way, the catch block can be empty. We can catch an exception and do nothing. That's also valid. In some cases, you know that something is happening, but you choose to ignore it. It's a valid scenario. So your program can also throw its own exceptions. So if you know that something is going wrong, or unexpectedly, you can throw an exception by using the throw keyword. And everything will behave just as you expected. The execution will stop, and it will start searching for the next closest catch block, and if there is no such catch block, you'll crash, and if there is, it will be caught. So that's how you can, if you have your own exceptions, you can throw them whenever you need, and of course you can throw other exceptions as well. Many times, for example, when you have a method that receives certain arguments, and you can check if the arguments are in the right format or in the right range. So I want a method that receives an integer that corresponds to an age, but if I receive -5, I can throw an argument exception and someone can catch it, probably me. That's a flow. We are, just as I explained, when we have an execution and a method calls a method, and then one of them throws an exception, we're going to find the closest catch block. They're going to start returning, and if nobody catches it, in any case, it's going to return back to the .NET framework, and since nobody caught it in the execution of the program will crash. It will go back to the framework, to the operating system level, and we'll get an error message like we did. If we catch it anywhere in the chain here, that should be good enough. Here's the throwing. When we're throwing, we need to instantiate an object of our exception. So usually you can instantiate it with no arguments, but the most common one is to provide some kind of exception message. For example, by the way, what we can see is that we have a try block. We're trying to parse a string, but if we have some kind of format exception, we're catching it, but then we're throwing a different exception instead. And here we're providing the original exception that we caught as an inner exception of the one that we're throwing. So whoever catches this exception can say an argument exception was thrown, but before that, a format exception was thrown. Here's another example. We are catching an exception here, a format exception. Again, we have the object. We're printing a message, and then we're throwing the same exception again. So we have our object. Instead of creating a new instance, we have already the instance, and we're throwing again. And again, just like in catch, that doesn't really have to specify anything. We can just throw without specifying anything. And if we caught something, we're just throwing whatever we catch. Why we need that depends on you.
When you are throwing, are we executing some code after that, or is
Once it's thrown, the code after will not be reachable. Once you throw, the execution of the current position stops and goes back. Whoever catches it on the way will catch.
it can use this return?
As a very ugly return, yes.
Very
I mean,
ugly.
because you are initiating a sort of a crash. Of course, it all depends on your architecture. At some point, we going very deep, and then we caught some kind of problem. Then we're throwing an exception. From that point, someone else along the chain will catch it, and maybe we'll throw it again with some more information, or maybe we want all the methods to throw at some point a uniform exception and catch it some other place, or maybe we don't want to catch it. So This whole thing is very dynamic. It's up to you to decide how you structure your try-catch blocks and what you do with the exceptions, which ones you're throwing. This is part of the architecture of every application that needs to be taken into account the problems that can rise and how to handle them. So here's an example of throwing an exception explicitly. So we are checking exactly here. We have a method of square root that we'll call math.squareRoot, but before that we are checking the value ourselves, just like we would expect this function to check, inspect the value, and if it's invalid, maybe throw an exception. So we can do that ourselves. In many cases, when you have your own method which expects some values, you will do the check yourself, and if it doesn't match what you would expect, you can throw an exception. Which here might be, I don't know, some kind of arithmetic exception if we leave it to the square root, but we are saying you didn't give the right argument range. So we can throw something which more suits our implementation in this case. So the user, if we are saying, okay, try to run it and then it will catch some arithmetic exception, the user might not know, or some other programmer who might work with this code might not know exactly what went wrong. But if we're saying, okay, you provided a wrong argument here, then they will know that they need to call this method in a different way. So we're trying to call it. It will explicitly throw the exception, and we will explicitly catch this kind of exception. We'll put a message and then throw it back. And actually, since this is the main, we're just going to throw and crash. So let's see a throwing. So we are calling our method. The value is -1, as we could see. Checking ourselves what the value is. Throwing an exception. Catching it on the nearest block. Message. We receive a specific message that tells whoever called this method, you're doing it wrong. The argument is out of range, not valid. And this is our message. So here it is. Actually, you could see that it's really not populating the exception message. It's populating the exception's parameter name field. And throwing it again. So now we really have a crash that nobody catches, and we're pretty much stuck. Running it without, you just get the crash after printing out and then crashing. Okay. So when you are planning your code, like I said, take into account the possible problems that you might encounter and which exceptions you might catch, how to handle them. You can throw your own exceptions. You can throw predefined exception types in the framework. Really up to you. So if you have some problem with one of the arguments of a method, you can call argument exception or argument null exception or argument out of range exception. If you have something which is not implemented and the user is still trying to call it in a way which is not supported, you can call not supported exception. Not implemented exception is a default exception if we are implementing a certain class, for example, that inherits some parent class and it has to override some methods. Then again, we'll see that when we're talking about inheritance. But the default will be that the methods which are not yet written, they will be put in your code automatically, and whatever they do is they'll just throw the not implemented exception. So if anyone tries to call this method, they'll get a not implemented exception until the programmer comes and fills in some of the body of the function. Function is method, yeah. And if you're not sure, you can always create your own, inheriting the exception, or just catch the most generic one, or throw the most generic one. Really up to you. It's always good to catch the right ones, throw the right ones, so that they'll be interpreted correctly and be handled correctly. There is another block which takes part, and that's the finally. Whatever happens, whether or not we're catching an exception, we can put a finally block that will always get executed no matter what. So if there is an exception, we might catch it and we might not, but whatever, we'll reach this block here, which will always get run. For example, again, parsing a number, crashing in case we have some problem, and we can put some handling. This is usually used for handling something related to the code that was executed here. If we have some kind of resources that we need to clean up, we need to do something which is related or not related to the problematic code, we can do it here in the finally.
Can I ask, we can do this without finally?
Yeah, you could.
Why we should use
It's more of a, let's say, organization of your code in a way that's related to the try-catch block. So, of course, once we are done here, if we catch the exception, we are continuing, and if we don't catch the exception, we are still going to get here.
Even without program instruction?
Yeah. Yeah. Yes. Yeah, it's like, yeah, if you have a crash which was not caught, the finally block will be executed and you will not reach the code afterwards.
Probably that's how they are handling these messages with numbers, with error numbers, with binary. Because sometimes the program is not crashing, it's just giving you an error number and continue, but you have this binary block probably, where it says this is your error, you're probably stopping there, it's not crashing.
Either that or it's a catch block. I mean, one of the two. It could be a catch block that handles the exception gracefully and just returns an error message.
But in this case, you can continue working with your program.
Yes?
But finally, you can
Yeah. Let's see both cases. So let's read something illegal. And the parse will fail. We'll print a message. And now we're in the finally block. And now we're continuing. Let's catch something else. Let's give a number too big. Trying to parse, and we have actually crashed. It's not reaching. Let's run it without. No, it is like I mentioned. It's more of the organizational of your program. If you reach out of the exception, then you will reach the finally code, and which is pretty much like the rest of the code, but it is structured in a way that can be related to the exception block. And let's give something valid. And we're still running into the finally code, even though we didn't catch anything.
This would be the case even without the finally.
No, because we have a return statement. Look at that again.
I see.
I'm reading a valid number. It's parsed successfully. It's writing the line. Here there is a return statement, so this should actually stop the execution, but the finally will be executed in any case. This code will not be run anymore. That's not our window. That's our window. That's the finally block.
It's an interesting way to write code after the return.
Yes. It's a hack. So, organize your catches correctly so that you know what you're catching, know what to expect, and always, when you are raising your own exceptions, put the right one, choose the one, give a good message so that whoever catches the exceptions that you're throwing will know what's going on. So exceptions are good tools to handle all kinds of scenarios, unexpected or expected scenarios in your program. So you have to consider which ones you're catching, in which order, what will be caught, what will be thrown, and that's quite important, and they can give quite a lot of information to the callers, and many times it won't be the same person who writes one piece of the code and catches it on the other side. In big projects it's very common, and exception handling is important. If you don't have a need for an exception, if you can handle the code nicely, for example, if you have a method that calculates the square root like we did, and you can just avoid calling the math.square root and throwing and printing a nice message to the user instead, then that's up to you. I mean, if you don't need an exception, don't put an exception, but if you do, then you have to choose the right ones. Yeah. Well, sometimes exceptions are thrown by the framework. For example, if you have a infinite recursion, you can get a stack overflow or a system out of memory if you overuse memory blocks. So sometimes you need to be prepared, but not every time your program can really know what's going to expect. I think there's nothing more to add much here. Any more questions? If we have a little time.
Actually, somebody using it is developing the exceptions. It's for testing, I think. Maybe you can use it as developer.
No, many times. No, many times exceptions are part of the program. You mean?
You can do something if, for example, the input is incorrect, then you can just execute completely different code with different values.
Yes, for example, if you look in a program like Excel and you are calculating the square root of a cell, and somebody comes and changes this cell to -1. Let's say at some point there'll be an exception, but you don't want the Excel to crash. It will just write in the cell error. So many times you can expect some problems and you can handle them gracefully instead of crashing. It's not just for testing. In many cases, applications need to have exception handling. It's part of the normal flow. It's important. And let's say you don't want your application to crash. Which exception you throw and when and where do you catch it is up to you to decide how you plan this. You can create your own exception classes, and for example, we can define a class that can inherit we haven't discussed inheritance much, but here's a class that inherits the exception class, or I can inherit from any other exception along the way. So now my program, since I have this in my context, my program can throw such an exception. It will be in a specific context to be expected. It will be caught in a specific way, and I'll know what it means. I mean, many times the framework doesn't have the exact coverage for the exception that I want to throw, but in the context of my program, it might be important, and I can, at any point here, let's put it a public class. At any point in my code, I can throw my own exception. I can give it any message I want. Well, it doesn't have a constructor with a message, really, but I can create it. And that's the way to inherit constructors action. So that's one way that you can handle your own errors, and you can control in a very customized way what your program is doing and catching. And of course, other more standard errors can happen in calculations, in arguments that are given. Something is null. Many times the framework methods, in many cases, if you have some authentication method or if you have calculation method and you're calling it and in some way it gets a null value, you'll get an exception. You might want to user input. Yes?
That it's not a good habit to handle user input exceptions. But
Yeah.
parse is a good way to catch.
You can try parse. You can look at the string yourself.
It's returning to bool value, so you can go.
You are distracting the flow of the program. Something went wrong when you're throwing an exception or catching an exception. Something went wrong enough. So think about it. If it really is necessary, if you're reading a string, you can do try parse. Or you can look into the string yourself and you can see what it contains in a way, and either throw the exception yourself or not. But in many ways, if you're talking about Windows applications like WinForms, or if you're talking about web applications like ASP.NET, you can have validators on your text fields, and you don't really need to wait for the input and then try to parse it and then crash. So if you can avoid getting to the point of crash, it's better, of course. But in many cases, first of all, in many cases, exceptions are thrown without your control. If it's a user input, if it's read from some database and it contains some invalid information, if it's not yet initialized, or it's not yet ready, or it's in some early stages of your program execution where you have null values in some point. So it's better to know what to expect, and if you know that this might crash, you can handle it yourself, or in some point handle it yourself and throw the right exception yourself, so that someone is using your method on the other side of the application, the other side of the project. They will try to execute their own code, and they will crash, and they will know that they're using your method wrongly. So, of course, if you can avoid getting into the mess and not doing the nice things gracefully without getting into the exception, that's good. But if you have no choice, and in some cases it's more explanatory on your program to have the right exceptions thrown and the right exceptions caught.
In the catch statement, we can't have return. Is it right, or we can't have?
I don't think you can have. Maybe you can. Yeah. It's valid. Yeah, it's valid. Yeah, looks like you can. But that means, as you can see, that this code is no longer reachable, and in that case, well, actually, because we have a return here too. So in any case, if we catch, we return. If we don't catch, we return. So that means this code will never be reached. But in this case,
for example, we can return the wrong signed value for the variable.
You mean inside a method? Like, for example, if this method would return an integer in a way. So you could return 0 in this case, for example. That could work.
I was thinking, I was trying to write some method which is canceling or returning a method, not the method which is asking for your method, the method before that. It's useful sometimes. I mean, you have 3 methods. The first one is coming to executing the second one. The second one is executing the third one.
Yeah.
And you want to cancel the first one without passing to the second, because the second one has some code, some program which you don't want to execute.
Yes.
But usually the stuff is executing the first one, you are coming to it, returning it, then it's going to the second one. But for example, in some recognitions and this kind of things, you won't just go to the main one. Cancel the second one. And in this case, you can do it with exception which is returning to the first one.
Yeah, either you catch it on the first one, or if you have such a hierarchy of 3 methods calling each other, you can catch it and you can throw it back to the second one, and the second one will throw it back to the first one. It could be also such a chain reaction of one exception is caught somewhere and then throwing it back to the intermediate one and throwing it back to the main, or throwing a different exception to the main.
I was trying to without the exception, it's really nice to have this.
Yeah, unless you catch it and then you return some special value which is handled then on the return. And yeah.
But then you always have this value, and if the code is correct, and you want to go to the second Telerik itself, it's possible to change.
It's true.
In the recursions, sometimes you need that because in cases where you don't know where exactly to cancel your recursions. There is, for example, this stack overflow. There are recursions which are becoming too big, and you can expect them to be solved.
Well, using an exception as the stopping condition of your recursion is not the best idea, I think. I mean, it's not the best methodology to say, okay, this recursion can stop either on this condition, or I'll just throw an exception just to kill it. It's
because you are stacking. In one case, when you have some exception, for example, you're going out of the int max file.
Yeah.
You don't want to go again back to all the recursions, because usually your stack is going back there. Then you won't just go to the method and cancel and say, okay, you overcode the
yeah, that's also a classic example of some error that occurred, but not as the stop condition of your recursion. I mean, if your recursion reaches some kind of end condition, then it has to return orderly. If there is some error on the way, like you really reached a number too big, then this matches a case of an exception that needs to be thrown. Yes.
Actually, the overflow of the data, sometimes it's not causing error and stopping the problem.
Depends
so
in which.
Then you really need to catch.
Depends on the flow. Again, if you're executing a method of the framework, you can always check which exceptions are expected to be thrown and in what cases. And the same goes for your own code. When you're documenting your methods, you should know what's going to be thrown and when. And it's part of a normal implementation. There is another article. This one, the exception model. If you really want to dive deep into the behind the scenes of exceptions in the .NET framework, how they're implemented, how they work with the CLR, that's quite a deep article. But if you have some interest, this can give you a lot of inside information. Just so that you know.
When you're writing a test for our program, is it the normal way to use exceptions?
Depends on the test. For example, I'll talk on my experience here in Sitefinity. We are covering our code with certain types of tests, several. One of them is unit tests. Unit tests means I have a specific method. For example, here's the method, and I want to check how it behaves in certain scenarios, when I send such an argument, when I don't send an argument, when I send null, and I can verify that it behaves like I want it to behave. So when you're testing your methods, you might want to see that if you're sending a null expression to it, you will get the right exception thrown. That you will get an exception thrown, and you can also verify that it's the right one. So you can expect in your test the exceptions as well as the non-exception scenario. So yeah, this is something which is common. It is again part of your plan, part of your code, Exceptions are ugly. I mean, at the first, when you start dealing with C# and you have some crashes, it's ugly, but then you learn that it's part of any code project. It's normal, and many methods throw them, and they are documented, and it's known that in certain scenarios your methods will throw an exception, and that's perfectly acceptable. It's if you can avoid it, of course, don't do it, but if something is wrong, do the right thing.
You can also look have a video in the other side of your keyboard. So
You always expect an idiot on the other side.
so that's why you get this.
Uh,
Even if you write please enter a valid number between 1 and 99, you can expect that somebody will enter wrong value.
yeah, they can make mistakes too.
And the error messages should be self-explanatory enough.
Yes, I agree. It's important. Not that I haven't seen Windows crashes with some weird error messages, and there are whole blogs full of wonderful error messages which nobody can understand anything. But you can just write something like catastrophic failure, and that should be good enough for everyone. More? Any more? Okay, then I think we're done.
Are we going to handle exceptions in our test? For I mean, the first one we expected the correct input.
Mm-hmm.
In the second one,
Since it's part of this part of the course, I would say probably yes.
but then the testing problem, then you expect the type of the exception. So you always go
Either it will expect to catch some kind of exception if it's expecting it, or it will expect you to handle an exception gracefully and not to crash. So either one of the two. All right. In that case,